we're shooting the Speer Gold Dot 230 grain 45 ACP in this HK45 Tactical. Target is 15 yards out. We're going to be running the lab radar chronograph to give us our consistency measurement. And from our bullseye target, we're going to be measuring precision and accuracy to round out the PAC test. Then we're going to slide over to the clear ballistics gelatin and run the terminal ballistics test with one round of the Speer Gold Dot. Let's go ahead and get this started. Arm the lab radar. We're out. Go ahead and take a look at how that impacted on the bullseye, then slide over to the ballistics gelatin test. You know, that went pretty well. I consider the Speer Gold Dot kind of one of those famous bullets, and I can see why it has earned some fame. The precision measurement was 1.54 inches, or roughly an inch and a half, 5-shot group at 15 yards, and we scored 42 out of 50 points. This factory ammo also performed pretty well on the chronograph, with a standard deviation of only 12.6 feet per second and a muzzle velocity, or average muzzle velocity, of 920 feet per second. But some of those measurements or some of those statistics kind of pale in comparison if the bullet doesn't perform as it should in the target. And since this is defensive personal protection ammunition, we expect that bullet to perform well in our ballistic gelatin test. Now this again is clear ballistics gelatin, 20% NATO block, and we are relying upon one bullet to be representative of what the Speer Gold Dot will do in a personal defense scenario. And I think that's actually pretty fair game, because any one of these bullets anywhere ever built or ever crafted by Speer could be one of those bullets that really has to be used in a personal protection scenario. We had an ideal 11.5 inches of penetration, 147% expansion, almost 150% expansion there, and once again retained almost all of its weight. 99% of the weight was retained. Now this is also interesting. I'm a reloader, hand loader, and sometimes, or often, I will weigh bullets, especially on my precision rifle loads. I'll weigh those bullets, and let's say it's a 168 grain 308 bullet. Well, a lot of those bullets really are not exactly 168.0 grains in weight. 0.1, 0.2, 0.3, 0.4, 0.5 grains different. Okay, so this bullet, it's factory ammo. I wasn't able to weigh it before it was loaded. So a lot of these bullets that we're testing might have actually been a little bit lighter in weight than 230 grains as is stamped on the box. And so whenever we're seeing 99, some percent, some high percent of weight retention, we pretty much are assuming that, yeah, that bullet retained all of its weight, unless we know otherwise by weighing the bullet before we actually loaded it. This bullet scored well in our ballistic gelatin performance test with 423 out of 500 total points available. And looking at some of the footage of that bullet as it entered into the ballistic gelatin and slowing it down, it's kind of impressive to watch it that way, no doubt about that. But I also like to look at that temporary wound channel or the transient cavitation channel. And it's just kind of impressive really to look at that and compare one bullet's temporary wound channel versus the other. I will say this, however, that even though it's very impressive to look at that bang, quick ballooning effect, that's not really where the damage is done by that bullet. Of course, it matters on what organs might be impacted by that essentially shock wave. But really, the majority of damage, as I'm reading some of the professional literature on this, the majority of damage is really done by two direct bullet effects. And principally, it's the crush effect of that bullet, and then secondarily, the stretch effect of that bullet as it's pushing an organ or whatever, and you're pulling it, stretching it, whatever, those sorts of things. But that's where the great majority of damage is done, and that's what these bullets, defensive bullets, need to be capitalizing on. And that's why some of these larger caliber bullets have really such a great effect. A 45 caliber bullet is quite a bit larger than a 9mm, and as it expands to 1.5 times, 1 3/4 times its original size, it has the capacity to do all the more crush damage just because that projectile is that much larger. And it comes down to just flat out basic physics when we're talking about this. So the Speer Gold Dot did a good job. It did better than the previous bullet that we tested, the Remington Golden Saber. We've got other bullets coming up in our PAC-T testing, and in our next video we're going to be looking closely at the Federal Hydra Shock bullet. Again, a 230 grain 45 ACP round, and I'm going to be using my HK45 with once again. Thanks for watching. Stay tuned. We've got a lot more PAC-T testing coming up, and if you're interested in seeing us test a certain bullet, let us know. We'll see if we can get that and run the test for you.